Good morning, all of you. In the last period, we have started the application of the Gauss law. And in the application of Gauss law, we have studied about the first application, that is spherical symmetry. And in that, we have to discuss the three number of cases, and we have to find the electric field. First of all, we have to find the inside, that is inside the Gaussian surface. We have to find the electric field intensity at the point, say, small r. First of all, we have to find the external point, then inside and on the surface. Three cases we have to discuss about the electric field. First of all, we have to say that E is equals to 1 upon 4 pi epsilon 0, that is Q upon small r square is the first case. Second case, we have to say that on the surface, that is E is equals to 1 upon 4 pi epsilon 0, Q upon capital R square. And finally, we have to obtain the electric field intensity, that is for the Gaussian surface. And in that case, we have to consider the last point is the internal point, and for internal point E is equals to rho upon R into 3 epsilon 0. These are the three cases we have to discuss. In the today's lecture, we are going to discuss a very important application. Many times question may be asked on obtain an expression for electric field due to a uniformly charged cylinder. Last period we have to obtain the expressions for sphere. Now we are going to obtain the expression for cylinder. First of all, we have to consider the diagram for the cylinder. Here we have draw a diagram, that is a cylinder. First we have to consider this is a infinitely long cylinder having a radius is considered as a small capital R, and Gaussian surface or Gaussian cylinder having a radius is say small r, and we have to find the electric field intensity at a point. This point is considered as say point P, and we have to find the electric field intensity at a point P, and P is at a distance is say small r, and here capital R is the radius of the inner cylinder, and small r is the radius of the outer cylinder, and inner cylinder is a charged cylinder and outer cylinder is a Gaussian cylinder. And here we have to find the electric field intensity at this point. We have to consider that is a electric field is exactly outward direction, that is E bar and ds bar is a perpendicular, is what we have to say that it is directly outward direction, and here E bar and ds bar in the same direction, and at the curved surface E bar and ds bar are perpendicular to each other. Here also we have E bar and ds bar is perpendicular to each other. First point we have to consider a infinite long cylinder of radius is considered as small capital R. Capital R, a radius of infinite long cylinder. Capital R is the radius of the infinite long cylinder, and having a charge density lambda is equals to charge per unit length. This is called as a charge density. It is measured in charge per unit length, means we have to say that it is measured in coulomb per meter. Charge is measured in coulomb and length is measured in meter. So the charge density, or sometimes it is also called as a linear charge density, and it is charge per unit length. Different types of density we have to know. That is last application we have to use a volume charge density. That is we have to say that rho is equals to charge per unit volume. Here the cylinder is, we have to consider say like a length like rod like cylinder. So we have to consider say length of the cylinder is say L, and we have to consider a charge density is a Q upon L. It is measured in coulomb per meter. And due to the symmetrical nature, field will be perpendicular to the axis of the cylinder and directed away from it. Symmetrical nature, this is what we have to say that cylinder is symmetrical nature, so that field is symmetrical. Due to the symmetrical nature, the field will be perpendicular to axis of cylinder. Field is perpendicular to axis of cylinder. See here, field is perpendicular to the axis of cylinder. Field is perpendicular to the axis of cylinder. Due to symmetrical nature, field is perpendicular to the axis of the cylinder. Now case number 1, if small r is greater than, case 1, if small r is greater than capital R. See here, capital R, small r is the radius of outer cylinder and capital R is the radius of inner cylinder. We have to consider the case that is small r is greater than capital R. And here, to find the electric field at a point P at a distance r from the axis of the Gaussian cylinder having the radius is say small r, we have to find field at point P. Find field at point P, because we have to say that Gaussian cylinder is considered as say having radius is say small r, and we have to target that is field at a point. Any point we have to find that is field is always remains, magnitude of the field is, we have to consider that always remains constant for every point. So we have to find the electric field at a point say P, and because cylinder is a coaxial and charged cylinder as shown in the figure. Two ends of the faces we have to consider here, two curved surface, two end of faces, two end of the faces, two ends of the faces we have to consider here, and in the two ends of the faces 1 and 2, the cylinder are perpendicular to the axis. Two ends of the faces, cylinder are perpendicular to axis. So E bar dot ds bar is equals to EDS cos 90, and that is equals to 0, because cos 90 is what? 0. And here we have to say that field into this one surface number 1 and surface number 2, that is two surfaces, that is 1 and 2 having field is what we have to consider say 0. Now field being a tangent to the surface, so it will be 0. The total electric flux due to entire Gaussian surface, total field due to the entire Gaussian surface. This is the Gaussian surface, and due to that Gaussian surface we have to find the electric field. What is the formula for electric field? That is phi is equals to integration total असल्यामुळे we have to consider the curved surface closed loop, and that is what we have to say that E bar dot ds bar, and that is equals to, we have to consider say E is outside and surface integration of say ds And what is the surface integration of what is the surface area of the cylinder? We know that we have to study in the 10th standard. What is the formula for surface area of the cylinder? That is 2 pi RL, and it gets that is phi E is equals to E into bracket 2 pi into R into L, where L is the length of cylinder. L is the length of the cylinder, lambda is the charge density, and so we have to find the electric flux. Total electric field due to the entire Gaussian surface is given by phi E is equals to E into 2 pi R L. This is equation number say 1. Equation number 1. After that we have to say that according to the Gauss law, we have to know that is according to the Gauss law states that electric flux of a closed surface is equals to 1 upon epsilon 0 times a total charge enclosed in that surface. That is phi is equals to q upon epsilon 0, and this is equation number say what we have to consider say 2. And after that we have to write that here, that is phi is equals to, from 1 and 2, 1 and 2, what you have to write that is E into 2 pi RL is equals to q upon epsilon 0, but from charge density, what is the value of q? Q is equals to lambda into L. E is equals to E into 2 pi RL is equals to lambda into L divided by epsilon naught. And here L gets cancelled. So E is equals to, we have to write that is lambda upon 2 pi epsilon naught into R, and this is the expression for electric field intensity due to its uniformly charged cylinder. This is the first case. E is equals to lambda upon 2 pi epsilon 0 into R, and from this we have to say that the direction of E bar is radially outward for a line positive charge. E bar is radially outward. Radially outward. This is the first case, and second case we have to discuss here, that is case number 2. What is the case 2 we have? That is, we have to consider first of all case is what? Small r is greater than capital R. Now we have to consider if small r is less than capital R, what will happen that? Small r is less than capital R. At that time we have to consider one more important point, that is the charge enclosed by the Gaussian surfaces that is we have to consider charge enclosed by the Gaussian surface is, that is q is equals to r square upon capital R square into lambda L. This is the charge we have to consider. According to Gauss law, what we have to say that E into 2 pi R L is equals to charge value is what? r square upon r square into lambda L. Here L gets, L is cancelled with this L. Then R is also cancelled with this R, and it gets that E is equals to, what we have to remember here, lambda into R divided by here 2 pi into, here according to Gauss law, one more term is that epsilon naught, and it gets that what? That is capital R square into epsilon naught. This is the formula. Very simple. We have to consider the electric field intensity. If small r is less than capital R, charge enclosed by the cylinder is, we have to consider r square upon r square, that is into lambda L. First case we have to say that charge is what? That is lambda into L, only lambda into L. Here we have to take what? That is r square upon r square into lambda L. This is the charge, and according to Gauss law, that is E bar dot ds bar is equals to q upon epsilon 0. Q is nothing but this one, and epsilon 0 is a constant, and then we have to say that E is equals to lambda r upon 2 pi r square into epsilon 0. This is the very important article we have to consider, that is electric field due to a uniformly charged cylinder. Many times question may be asked on that for 10 marks. Derive an expression for electric field intensity of a charged cylinder and discuss the two cases if small r is less than capital R and capital R is, small r is greater than, first case small r is greater than capital R, and second case small r is less than capital R. And from these cases we have to very important formula, that is E is equals to lambda upon 2 epsilon 0, 2 pi epsilon 0 into R. First case E is equals to lambda upon 2 pi epsilon 0 into small r. And second case, what we have to say, that lambda r into lambda r divided by 2 pi r square into epsilon 0. This is very important. First of all, we have to draw the diagram. In the diagram, first we have to explain the information about the diagram. What is the information about the diagram? First we have to say that consider a long uniform cylinder having radius is, say, capital R, and it has a two curved surfaces, and here we have to consider a Gaussian cylinder having radius is, say, small r, which is symmetrical to the smaller cylinder. And finally we have to find the field at point, say, P, and field is always perpendicular to the axis of the cylinder at every point. And if we have to consider a two curved surface, at that time we have to consider that the here angle between area of the surface and the field is, say, perpendicular to each other, so that field at that point is what? 0. Curved surface ची field ही 0 आहे. We have to find a field, electric field due to a entire Gaussian surface, and which is given by phi is equals to E bar dot ds bar, and that is ds is nothing but the surface area of the cylinder, and that is what we have to say, that 2 pi rl. You have to know this formula and substitute that value according to the Gauss law. We have to say that according to the Gauss law, entire flux is equals to entire flux over a closed surface is equals to 1 upon epsilon 0 times net charge enclosed by that surface. And then from equation 1 and 2 we have to say that is E into 2 pi rl is equals to Q by epsilon 0, where Q is a charge, and that is nothing but the charge density. Lambda is equals to what? Q by L, linear charge density, and Q is equals to lambda into L. Here L gets cancelled, so E is equals to, here multiply factor is what? 2 pi r comes here, lambda upon 2 pi into r into this epsilon 0, and this is electric field which is always radially outward. If small r is less than capital R, the charge enclosed by the Gaussian surface is r small r square upon capital R square into lambda L. This factor we have to remember for writing the expression that is r square upon r square into lambda L. According to the Gauss law, we have to say that is E bar dot ds bar is equals to surface integration of E bar dot ds bar is equals to Q upon epsilon 0. Q is nothing but r square upon r square into lambda L. Epsilon 0 is as it is, and r and L are cancelled. So we get E is equals to lambda r upon 2 pi r square into epsilon 0. This is the electric field intensity, and it is always directed along the outward direction. We have to consider in vector form. We have to write that also. E is equals to lambda r 2 pi r square epsilon 0 into r cap. R cap is the unit factor. This is about the expression for electric field intensity of uniformly charged cylinder. Write down every points. Very important article.